All right. The last part of this problem actually is a different concept. So the last video got too long and I needed to stop it, but also because this video is going to deal with another concept called percent yield. Notice that this says limiting reagent. We figured that out. We did some product conversion with knowing what the limiting reagent is, and now percent yield. So we have to do percent yield. It's not the same thing as percent error. No. This is not percent error. What percent yield is? Okay, you're getting a percent. Whenever you get a percent, you always take partial and divide it by whole, no matter what you're doing. Percentages are partial divided by whole, or the total. In this case, percent yield. Okay, let's see what we got here. This problem says if 11.3 grams of the sodium chloride are actually formed in the reaction, described in the problem above, what is the percent yield of this reaction? So our percent yield is going to be equal to partial divided by a whole. Well, that's any percent. But in this case, what does that mean, the partial? Partial is what you actually do get. So I cannot write and talk at the same time, so that was not a good talking and writing. Actual. Okay. I'm not good with that. Sometimes I'll just be writing on the board, and if I'm talking and I'm thinking of something else, I'll start writing what I'm thinking, which is not a good thing. Okay, not good. So don't write and talk. Partial means actual, the value that you actually got in the experiment. So the stoichiometry, when we did that math earlier, we had calculated, and I jotted it down over here before I knew I was going to forget, so I jotted it down. The math told me, the stoichiometry told me, we would produce 12.8 grams of silver, or the sodium chloride. You remember earlier I said we're going to convert this sodium chloride from moles to grams, because we're going to need it. We're going to need it now, that's why. So I wrote that down, 12.8 grams. That's what the math says I should get. The calculations say you should get 12.8 grams. Okay, then we go and you do the lab. You do the experiment, and you don't get 12.8 grams. We got 11.3 grams. So that's the partial out of the total that we could have gotten. The whole is what that's short for stoichiometry. What the stoichiometry says, what the math says we should get. So this is what the math says. So our percent yield is going to be what we get in the experiment divided by what the math or the stoichiometry says we should get. So this would be what we should get in a perfect chemical world. If everything goes 100%, there are no lab errors, you're not spilling anything, and here's those other things as well. Sometimes what you ends up happening, you get products which then react with each other and actually go back and reform the reactants. That's called a reversible reaction. There's all kinds of things that can be going on that will cause you, not just like spilling something, but actual chemistry stuff that will give you an answer lower than what the math says you should get. So the percent yield would be actual divided by the math, the stoichiometry, and the actual in this problem is 11.3. So person does the lab, they come out with 11.3. The math, remember, told us we should get 12.8 grams, 12.8 grams of the sodium chloride. Now, to get anything into a percent, of course, you've got to take this and multiply it by 100. This is going to give you a decimal. So multiply by 100. And boom, we'll get our percent yield. Now, I'll tell you what, in industry, percent yields in the 60s are pretty good. This isn't percent error. This is not percent error, so don't go thinking that. If you get a 60+% yield, you're doing well. So let's see what we got here. How well did this person do? 11.3 divided by 12.8. Nice. They got 3 significant digits. An 88.3% yield. That's pretty good. And an 88.3% yield. So that would be a nice percent yield from what you actually get compared to what the stoichiometry says I should get. Now the math, the stoichiometry, when you do the math, it doesn't deal with anything, things reacting with each other, reversible reactions. It doesn't know about that. You as a chemist or a chemistry student, well now you know that can happen. So in that case, you're not going to get 100%. It's not going to happen. Okay, all right, okay. And there also would be experimental error would be involved as well. So that does not give you a high percent yield typically. Now, even by high percent yield, 60% and above. Okay, so now we have our percent yield. That was pretty quick. That's one of the quickest videos you watched in a long time. And that's it for this video. Percent yield. We're good. We're good. Got it. Okay. Woo!